In this video, I will show you how to find the intervals on which the function is increasing or decreasing. We know that a function will be increasing if the first derivative is positive and decreasing if the derivative is negative. So our strategy will be to find the derivative and then figure out where it is positive and where it is negative. So let's go ahead and find y prime. This will need the chain rule. So first we take the derivative of the outer function by moving this 2 to the front, reducing this power by 1, so nothing. But then we do have this inner function, and the chain rule says we need to take the derivative of the inner function and multiply by that. But the derivative of x plus 1 is just 1. And we don't really need to show multiplying by 1, so I'm just going to erase that. So this is the derivative. In order to determine where y prime is positive and negative, we're going to need the critical numbers. In general, the critical numbers occur when y prime is equal to 0 or when y prime is undefined. However, this is a polynomial equation, so there is nowhere that y prime is undefined. So we will just focus on finding where y prime is equal to 0. So if I set this equal to 0, I have negative 2 times x plus 1 equals 0, which tells me by the zero product property, x equals negative 1. So this is my only critical number. Next, we use the critical number to make a sign chart. Think of this top line as a number line. So I'm going to put the negative 1, that critical number right here, dividing the number line into an interval to the left and an interval to the right. Next, we look at the factors, which we had set equal to 0. One of those factors is negative 2, and the other factor is x plus 1. Let's consider the sign of each one of these values to the left and right of negative 1. Well, obviously, negative 2 is always negative, so I'm just going to mark these intervals as negative. And x plus 1 will be negative to the left of negative 1, but this will be positive for values of x that are greater than negative 1. So in this first interval, we will have a negative times a negative, which is a positive. And in the second interval, we have a negative times a positive, which is a negative. Also, we should label this whole graph as a sign chart of y prime. So remember, we know that the function will be increasing where f prime is positive and decreasing where f prime is negative. So that means the original function will be increasing in this interval and decreasing in this interval. So let's begin to summarize. We will say y is increasing on the open interval from negative infinity to negative 1. That's what the sign chart is telling us, from negative infinity to negative 1. Because y prime is positive, or y prime is greater than 0. So notice how I am justifying my answer. That's a good habit to be in. Similarly, we say y is decreasing from negative 1 to infinity because y prime is negative. Go ahead and pause the video and try to do this one on your own. Alright, so we have learned that the first step is to find the derivative, so we can see where that is positive or negative. So the power rule says 4x to the third power minus, alright, 2 times 2, so that's negative 4x. So there's the derivative. Now we find the critical numbers based on where f prime is equal to 0. Ordinarily, we would also ask where f prime is undefined. However, this is a polynomial, and there's nowhere that a polynomial will be undefined. So we can just focus on setting f prime equal to 0. This is factorable, so I'm going to go ahead and factor this as I set it equal to 0, and we will have 4x out in front, and then x squared minus 1 is equal to 0. This can be factored more, the difference of two squares, so x plus 1 times x minus 1 is equal to 0. Setting each of these factors equal to 0, I get the following three critical values. X is equal to 0, x is equal to -1, and x is equal to +1. Now I'm going to make my sign chart by placing these three critical numbers on the number line in order. So I've got -1, 0, and +1. Now let's make a row for each of the three factors that we have. So we have a row for 4x and x plus 1 and x minus 1. Also, very important, let's label the sign chart as pertaining to y prime. So let's look at each factor in each interval and decide if that particular factor will be positive or negative in that interval. So 4x will be negative whenever x is negative. So anything less than 0 will make 4x negative, and anything greater than 0 will make 4x positive. What about x minus 1? Well, this equals 0 when x is -1. So it'll be negative for values of x that are less than -1, and it will be positive for any value of x that is greater than -1. And then what about x minus 1? Well, this factor equals 0 when x equals 1. So it will be negative to the left of 1, all right? Any x value less than 1 will cause x minus 1 to be negative, and any value greater than 1 will cause x minus 1 to be positive. So count the negatives. In this first column, we have an odd number of negatives, so that's going to make the overall result a negative. So we have a negative times negative times negative gives you a negative. In the next column, we have a negative times a negative, which is a positive. In the next column, we have a single negative, so this will be negative. And in the last column, these are all positive, so this column will be positive. Remember, f of x will be decreasing in the intervals where y prime is negative, and f of x will be increasing in the intervals where y prime is positive. So let's summarize our answer. I just noticed that I had been calling this y prime on the chart. Let's call it f prime. So we say f of x is increasing from -1 to 0 and from 1 to infinity because f prime is positive. And f of x is decreasing from -infinity to -1 and from 0 to 1 because f prime is negative. In number 8, we will do the same thing, only to find the derivative, we will need the quotient rule. Do you know the quotient rule poem? When I say d high or d low, I'm talking about the derivative. So the poem goes, low d high, less high d low. Draw the line, and down below, the bottom squared will go. So let's give it a try. Y prime equals low d high. When I say low, I just mean write down the bottom expression. So we have 2x minus 1. Low d high. D high means the derivative of the top expression. which will just be 2x. So we have low d high less high d low. Less means subtraction. High d low. High means write down the top expression. And then d low means write the derivative of the bottom expression, which will be 2. Draw the line, and down below, the bottom squared will go. So here is our derivative. I am going to simplify this though. Distributing the 2x and really just putting the 2 in front, you get this. But now we have like terms. 4x squared minus 2x squared is 2x squared. So we have this. But now I see that there is a common factor in the numerator. Let's factor 2x outside the parentheses. Now it's time to find the critical numbers. The critical numbers are the values that cause y prime to equal 0 or be undefined. The y prime will equal 0 when the numerator is equal to 0. So looking at the factors in the numerator, that tells us x is equal to 0 and x equals 1. These are the critical numbers so far. Y prime will be undefined when the denominator is equal to 0. Setting this equal to 0 gives us x equals 1/2. So we have these 3 critical numbers. Next, you use the critical numbers to set up a sign chart. So I'm marking off this number line with my critical numbers in order. 0, 1/2, and 1. The sign chart will need a row for each factor in the derivative. So I see that I have 3 factors in the derivative, so I will need 3 rows. Here are the 3 factors, and don't forget to label the chart as pertaining to y prime. Now we need to determine the sign of each factor in each of the intervals. 2x will be positive whenever x is positive. In other words, 2x will be positive to the right of 0 and negative for values less than 0. The factor of x minus 1 equals 0 when x is equal to 1. So 1 is sort of the cutoff. When x values are less than 1, x minus 1 will be negative. If x is greater than 1, then x minus 1 will be positive. The third factor is being squared. So no matter what x is, the overall value of this factor will be positive. Now consider the number of negative signs in each row. Each column. The first column has 2 negatives. So a negative times a negative is a positive. We have a single negative in the second column, so this will give us a negative. A single negative in the third column gives us a negative, and we have all positive in the fourth column, so this will give us a positive. Remember that our goal was to find out where the function y is increasing or decreasing. Well, the function will be increasing wherever y prime is positive, so this interval and this interval. The function will be decreasing where y prime is negative, so this interval and this interval. Let's summarize our answer. For the final answer, we say y is increasing from negative infinity to 0 and from 1 to infinity because y prime is positive. And y is decreasing from 0 to 1/2 and from 1/2 to 1 because y prime is negative. Let's do the same thing for number 10. Start by finding the derivative h prime. The derivative of 12x is just 12. And then the derivative of x to the third power is 3x squared. So we have the derivative. In a moment, we will need the critical numbers. those will be easier to find if we write this derivative in factored form. I'm noticing that we have a common factor of 3. So let's take 3 outside the parentheses, and that will leave 4 minus x squared. Now I'm noticing that we have the difference of two squares. 4 minus x squared can be further factored as 2 plus x times 2 minus x. Now let's find those critical numbers. Critical numbers are values of x that will cause h prime to equal 0 or cause h prime to be undefined. Since h prime is a polynomial, there is no value that will cause it to be undefined, so we can forget about that. So where will h prime equal 0? Let's just set it equal to 0 and solve. So if we set 3 times 2 plus x times 2 minus x equal to 0, we get x is equal to negative 2 from this first factor, and we get x is equal to positive 2 from the second factor. So these are the two critical numbers. Next, place the two critical numbers on the number line to build a sign chart. So in order, we have negative 2 first, and then positive 2. We're going to need a row for each factor of the derivative. So I can ignore the 3, that's always positive. So I'm just going to have 2 rows, one for each of these two factors. Don't forget to label the chart as h prime. So look at the factor of 2 plus x. Where will this be positive and where will it be negative? Well, this factor equals 0 when x is equal to negative 2. So that's sort of the cutoff. So it'll be negative for any value less than negative 2, and it will be positive for any value greater than negative 2. You need to be a little bit careful with the second factor because of the way it's backwards from what you're used to. Think about the x value that will cause this to be 0. Positive 2. 2 minus 2 is 0. So you know this is the cutoff. So pick a value less than 2. For example, 0. If we had 2 minus 0, that's going to be 2. That would be a positive number. So that tells you that values to the left of 2 will give you a positive, and values to the right of 2 will give you a negative. For example, 3. 2 minus 3 would be negative 1, so that makes sense. Now, let's judge the sign of the overall derivative. In the first column, we would have a negative times a positive. That's a negative. In the second column, this would be a positive times a positive, which would be a positive. And the third column, positive times a negative, is a negative. Remember, our overall goal was to find where function h is increasing or decreasing. H will be decreasing wherever h prime is negative, and h will be increasing where h prime is positive. So let's summarize our results. We say h of x is increasing from negative 2 to 2 because h prime is positive. And we say h is decreasing from negative infinity to negative 2 and from 2 to infinity because h prime is negative. Before we take the derivative of this function, I will first rewrite it a little bit. This is the same as x plus 9 x to the negative 1 power. I just brought the x out of the denominator. So y prime equals 1 plus, now I'm doing the power rule, so negative 1 times 9. In fact, let me erase that and put negative 9 x to the, decreasing this by 1 gives me negative 2 power. So this is the derivative. I am going to go ahead and drop this back down to the denominator. So this would be 1 minus 9 over x squared. In order to find the critical values later, I really need this to be written as a single fraction. So the value of 1 is very special because I can rewrite that as 2 over 2 or 3 over 3 or x over x or x squared over x squared. Obviously I'm picking this, so I will have like denominators. Now I will combine my like denominators and get x squared minus 9 over x squared. Might as well write this in factored form because that will make it easier to find the critical numbers. This is the difference of two squares, so we can write x plus 3 times x minus 3 over x squared. So let's find the critical numbers. The critical numbers occur wherever y prime is equal to 0, and they occur where y prime is undefined. So y prime will equal 0 when the numerator is equal to 0, and looking at these factors, we can see that will happen when x is equal to negative 3, that's the first factor, or when x is equal to positive 3 from the second factor. So we have two critical numbers so far, negative 3, positive 3. The value that will cause the derivative to be undefined would be an x value of 0 because of that denominator. So we will add x equals 0 to the list of critical numbers. Now we will take these three critical numbers and put them on a number line to make a sign chart. Let's put those critical numbers in order. So we will have negative 3, 0, and 3. Now I'm going to make some rows. I'm going to need a row for each factor of my derivative. So I will need 3 rows. Don't forget to label your sign chart as pertaining to y prime. So here we go. The first factor of x plus 3 equals 0 when x is negative 3. So focus on negative 3. Any value that's less than negative 3 will cause this to be negative. Any value that is greater than negative 3 will cause x plus 3 to be positive. X minus 3 equals 0 when x is positive 3. So focus on positive 3. Any value that is less than positive 3 will cause x minus 3 to be negative. Any value that is greater than positive 3 will cause x minus 3 to be positive. Of course, x squared will always be positive because it's something squared. So let's look at each column. If I have a negative times a negative, that's a positive. If I have a positive times a negative, that's a negative. All right, I have a single negative in the third column, that's going to give me a negative. All positives in the last column, so that is a positive. Remember, our overall goal is to find where the function is increasing and decreasing. The original function will be increasing when y prime is positive, and it will be decreasing when y prime is negative. So we can see our increasing and decreasing intervals. Let's summarize our results. We can say y is increasing from negative infinity to negative 3 and from 3 to infinity because y prime is positive. And y is decreasing from negative 3 to 0 and 0 to 3 because y prime is negative.